A 3 kilogram steel block is at rest on a frictionless horizontal surface. A 1 kilogram lump of clay is propelled horizontally at 6 meters per second toward the block as shown in the diagram below. Upon collision, the clay and steel block stick together and move to the right with what speed? Okay, so to solve this problem, there's two concepts we need to apply. The first is the law of conservation of momentum, which tells us that the system momentum before an event, like a collision, is equal to the system momentum after that event, assuming that the system remains closed. And the other concept is that momentum is the product of mass and velocity, and of course momentum is a vector quantity. Okay, so how about we start by determining the system momentum before the collision. So that will be momentum 1, which is the momentum of the clay, plus momentum 2, which is the momentum of the steel block. And here we're going to consider to the right to be positive, as is the convention. So our system momentum before the collision will be momentum 1 plus momentum 2, which is the mass of the clay, 1 kilogram, times its velocity, positive 6 meters per second, plus the mass of the steel block, which is 3 kilograms, times its velocity, which is 0. So the initial system momentum boils down to the momentum of the clay. So we'll have 1 kilogram times 6 meters per second, which gives us 6 kilogram meters per second. So that's the system momentum before the collision, which we know, maybe I'll write it in variable form, which we know is equal to the system momentum after the collision. We're told that the two objects stick together after the collision, so this momentum after the collision will be their combined mass times their combined velocity, which we'll just call v. So if we solve for the combined velocity here, by dividing both sides by m1 plus m2, we end up with combined velocity equals final momentum divided by m1 plus m2. Keep in mind, final momentum is the same as initial momentum. We know the initial momentum to be 6 kilogram meters per second, so we can substitute in our values here. 6 kilogram meters per second divided by the combined mass, 1 kilogram plus 3 kilograms. So this boils down to 6 divided by 4, which is 1.5. Our units will be meters per second. So keep in mind that this is positive, which means that that velocity is in this direction. In this case, we're only looking for the magnitude of the velocity, or the speed. So this answer also satisfies that requirement, and it is the answer that we're looking for.